Hello class, this video is the answer key for the energy concept review that is found on my website. If you haven't had the chance to, try the worksheet on your own and then watch this video so you can get the answers, or vice versa. Watch this video and try the worksheet and see if you actually understood the content. Alright, so the first question asks, what are the three types of mechanical energy that we discussed and explored in class? So the three types of mechanical energy, and that's energy that you can get by doing work to an object, is potential energy, okay, like right here, kinetic energy when the object drops, and spring potential energy. Alright, so when you pull on a object attached to a spring, you're doing work, you're giving it energy, right? Changing energy. What are ways that we can increase mechanical energy of a system? What ways can we decrease mechanical energy of a system? Now, in the definition itself of mechanical energy, we can actually see how we can increase the energy or decrease the energy. Because mechanical energy deals with work, the more work you do to an object, you are increasing the mechanical energy of a system. If you were to do negative work on an object, you would decrease the mechanical energy of a system. For example, if this pebble right here is my object and that's my system, if I want to increase the mechanical energy, I would raise it up. I would do work on the pebble. If I want to decrease the mechanical energy, I would do negative work and I would lower it. Okay? Losing energy. How can a system seemingly lose mechanical energy? Where does this energy go? Transform into? What do we call this type of energy? Now, so far in class we discussed two types of energy, mechanical energy and thermal energy. So you either have one or you have the other. And you get thermal energy through mechanical energy. And that's why when you drop a basketball in the middle of a basketball court, it doesn't always bounce back up to its initial height. Because according to the law of conservation of energy, if you started off at a height of 2 meters, it should always bounce back up to 2 meters, but that's not the case. And that's because some of that mechanical energy transforms into thermal energy, and we get that through friction and heat and other types of thermal energy. Okay? Alright. Draw different energy bar charts to depict the three different paths: initial height, impact, and final height. Now, in order to demonstrate this, I'm going to use a simulation that we're all fond of, the energy skate park. Alright, what I'm going to do is I'm going to do work on the skateboarder. So if I raise it up, look at how the total mechanical energy increases. If I decrease it, or decrease the height, notice how the total energy also decreases. If I were to move it side to side, doing my best here to keep it consistent, notice how the total energy doesn't really change. Okay? And that's because your force and your direction must be in the same, axes in order for work to happen. So if I'm lifting an object up, I am exerting a force up, right? If I exert a force up and it goes up and down, I am doing work. However, if I'm holding the object up, but if I'm moving side to side, I'm not doing any work because I'm exerting a force in the y direction as moving the x direction. So if I were to put the skateboarder on this ramp, okay, look at how the potential energy is right now equal to the total energy, and I let go. And I push play, and look at what happens. The potential energy decreases and kinetic energy increases, and that's what we call a inverse relationship. Okay? And then as soon as he jumps off, his height increases. And once again, if his height increases, his potential energy increases. So he goes up, okay, and so far what we can tell is that the mechanical energy, kinetic plus potential, is equal to the total. But as soon as he lands and he makes an impact with the ramps, he's losing some of that mechanical energy and it will transform into thermal energy. Ready? Let me slow this down a bit so you can see this happen. Boom, right there. Instantaneously, as soon as he made that impact, some of that mechanical energy turned into thermal energy. Okay, so he goes up and he goes up and he goes up, and he's going to make one more impact. Now, when he makes an impact, he'll still be moving. So I want you to take a look at the kinetic energy bar in relationship to the total energy and the thermal energy. Okay, watch. Did you see that? Okay. When he slowed down, he lost kinetic energy, and it all turned into thermal energy, and that's because of friction. Okay? Between the skateboarder's wheels and grass, there's a lot of friction. All right. Kinetic energy. Describe what happens when an object's kinetic energy decreases. Okay, let's do the first part first. When an object's kinetic energy decreases, the object is either A, losing velocity or losing speed, or B, it's gaining potential energy, meaning that in terms of the ground, the height is increased. Describe what happens when an object's kinetic energy increases. So when an object's kinetic energy increases, the velocity is increased, or if it's during a drop, it's getting closer and closer to the ground. Okay, so if I were to ask you a question about something like this, if we were to triple the object's velocity, what would happen to the kinetic energy? In order to solve that problem, there are two different methods. You can solve the kinetic energy equation in terms of V, meaning you have V is equal to 2ke divided by m, square root all that. Or you can plug in numbers. For example, I like to make my math easy, so my mass, I'll make it 1, and my velocity, I'll make it 1, and I'll find out what the kinetic energy is equal to, like so much joules. And then, if the question asks what happens if you triple the velocity, okay, if my original velocity was 1, triple that would be 3. Okay, I'll plug that into the equation, and I'll see exactly how much of it changes. Okay. Potential energy. Describe what happens when an object's potential energy decreases. So when an object's potential energy decreases, if we take a look at the equation here, in order for the object's potential energy to decrease, assuming that the mass is the same and gravity is the same, is to make the height decrease. So when an object falls down. Okay. Now, in physics, in our class, we will hardly ever have a scenario where the mass actually changes. As my college professor liked to say, the only time an object's mass changes within a system is if it's an elephant with massive diarrhea. That's the only time. Okay. Describe what happens when an object's potential energy increases. So in order to increase potential energy, you have to increase the height, right? Now I want you to take a look at this picture here of this muscle man lifting up this ant. Okay, when he's lifting up this ant, he is doing work because he's exerting a force up, and the ant is moving up. Remember, same axes, it does work. Different axes, no work. And we know that the equation for work is force times distance. So if we take a look here at the potential energy equation, we know that force is mass times acceleration. Okay, mass, acceleration, times height. Okay, or times distance. And for us here, we have distance as height. So you'll notice that the amount of work you do to an object is the amount of potential energy that it gains, and that's what we call the work energy theorem. Okay? The amount of work you put into an object, the amount of energy that it gains. Okay. So once again, study hard. Try these questions out for yourselves. And if you have any questions, feel free to ask me in class. Thank you.